Hello, today we'll be doing Leetcode number 680, valid palindrome 2. Now for this example, we are given an input string and we are to return true if that string is a palindrome after removing either 0 or 1 character from it. So at most 1 character from it. And here we can see that in the first example, we have the string ABA, and this is just a palindrome without having to remove any character from it, so we turn true. And then we have the string ABCA, and here we can actually either remove either C or B, and we would get ABA or ACA. Both of these are valid palindromes, so we would return true. For the last example, however, we can see that removing any of these characters would not give us a valid palindrome, so we would return false. And just to kind of give a longer example, here we have the string ACDDA, and we can see that if we were to remove the character C, we would have a palindrome ADDA. So how can we go about solving this problem? So of course the brute force solution would be, well, first we would check if this entire string is a palindrome, and if it's not, then we will just go about deleting each character at once, one per time. So how can we solve this problem in linear time? Well, what we could do is take kind of a two-pointer approach to it. So we would have a pointer on the left and a pointer on the right, and we would just compare the characters at these points, and if they are the same, then we will continue, but if they're not, then we would move one of the pointers, and we would continue comparing the rest, and if the rest of the string is still invalid, then we know that it's not possible for this to be a valid palindrome, because that means that we would have to delete more than one character. So for this example, we compared A and A. Those two are the same. Great. Now we move to C and D, and we can see that here these two characters are not the same. So what we could do is move one of the pointers over, and this would act as if we are deleting one of the characters from the string. And we would keep comparing, and if this is still not the same, then what we could do is we could go back and we would move the other pointer, but in this example we actually just needed to move that C pointer, and after doing that the rest of the string would be a valid palindrome. Now just to show a string that would not work, here again we start at the left and the right, and we can see that these two are not the same character, so we would move in one of the pointers and we would keep comparing, and we see that it is still not equal, so we go back, and this time we move in the other pointer, and we would see that great, these two characters are the same. Now we continue in, and now we see that these two characters are not the same again, but we've already removed one character on the left and on the right, so this means that we would have to delete more than one character for this string to be a valid palindrome. So this would not be a valid palindrome. So onto the coding solution. As I mentioned, we will be doing a two-pointer approach. So here I have the left pointer and the right pointer starting at the beginning and the end of the string respectively. And we will traverse through the string using these pointers. So we will check if the characters at these pointers are equal. And if they are equal, then we will move in the pointers. And if they're not, then we will just break out of this loop and we will start moving in our pointers. And if we've never reached this else, then we can do a check to see if this left pointer moved past the right pointer, because if it did, then that means it finished checking the entire string, and that means that this is a valid palindrome without having to remove any character from it. Now, uh, if we go past this, that means that this didn't finish the entire string, so that means we will have to start removing one character from the string, and we will simulate that by just appending one of the pointer forward and continue checking. So we will do this twice, once for the left and once for the right. And if the left doesn't finish, then we will restart and we will go to the original, but we will start at the right instead. So here I will go ahead and append the left. It doesn't really matter which order you do it in, as long as you do append both. So now I will just redo the same loop, but using these new variables. Now we know that it's the same condition as up here. If x went past y, then we know that it finished checking the rest of the string, so we can go ahead and return true because it is a valid palindrome after removing one character. Now, if it were to not execute this, then we know that after removing the character that was on the left, it still was not a valid palindrome. So what we need to do is remove the character that was on the right, and we can do this by appending the right instead of the left pointer. And we will just go ahead and run the same exact loop. And in the end, we can just return if x is greater than or equal to y, because this means if this returns true, then we know that it went past y and that it is a valid palindrome because it finished checking the entire string. But if it didn't, then this would return false because it didn't finish, and it braked out of the loop because the characters weren't equal. So I will go ahead and submit this. So I've accidentally made some typos here. This equals should not be here, and this should be an S and not an R. So as we can see, the solution worked and we get pretty good memory usage. Of course, this code is a bit on the longer side, and I know that you can use the Python string split, and instead of using the while loop, we can just reverse the strings at the new points whenever we get a different character, but that would cause us to need to use new strings and give us extra memory. And with this solution, we do not use any extra memory because we only have those two pointer variables. But let me know if you like this video by liking and subscribing to this channel. If you have any questions, let me know in the comments below. Bye!